Today I'm just going to talk about three topics. One is the statewide pavement condition. The second is the changes that are coming into PMIS data collection. And I'm going to also discuss or give an update on a PMIS working group that we started working on. This is the chart for the statewide pavement condition scores. As you can see, in 2016, we've seen an improvement, and the scores went up to 87.32, which probably like the third highest score over the last several years. I think some of the additional money that we got from Prop 1 may have contributed to this improvement. And I hope that these improvements that we made, that we're able to sustain them. Because if you look at this chart, every time we made the gains, we lost them and then we recover again. These are the statewide trends for the statewide. Our condition scores improved, our distress scores improved, and our ride scores improved. And for the interstate, we have the distress improved, but ride and condition did not improve. The same for the U.S. highways. For the state highways, we had the distress improve and the condition improve. And for the FMs and our flexible pavements, all the scores improved. And for CRCP, we had our distress go down a little bit, but condition and ride improved. And for JCP, we had the distress and condition go down, but the ride improved slightly. And these are the trends in the distresses of what went up and what went down. This kind of gives an indication of what are kind of the trends, the distresses that are kind of causing our scores to go down. As you can see, for flexible, we're seeing more alligator and more failures. For CRCP, more spole cracks and punch outs. For JCP, we're seeing more failed joint cracks, shattered slabs, and patches. Again, this is the first increase since 2013, and this is the third highest, like I mentioned, since 2002. The next topic I'm going to cover is the PMIS data collection. We did a pilot study in 2014. We invited 2 vendors to collect data, kind of automated / semi-automated, for a couple of districts. And we awarded for 2 vendors, and the University of Texas at Austin did an evaluation of this pilot study. The 2 districts that were collected were Bryan and Houston. We wanted to kind of select districts that have a variety of pavement types and also a variety of surface distresses. We didn't want to go to a district where the percent good or better is like 92 or 91. We wanted to kind of challenge the system, test on concrete, test on hot mix, test on jointed concrete, test on kind of a variety of conditions. And this slides, you see these 2 pie charts. One of them shows you the surface types that we collected on, and the other one will show you the highway systems that we collected on. So we collected on ACP, composite pavements, surface treatments on concrete, CRCP, and jointed. And also we collected on interstates, US, SH, FMs, and also kind of secondary roads like business routes, etc. The next few slides, I'm going to show a comparison between the scores from our current process versus the scores from the automated process. So this slide shows the percent lane miles, good or better, for the Houston district and the Bryan districts combined. And we kind of did the comparison with kind of the exact miles that we had from the vendor, and we compared them with the corresponding miles that we had from our process. And as you can see, for vendor 1, you know, our scores dropped from 82.4 to 76. And for vendor 2, it drops from 82.4 to 78.4. And if you look at a district by itself, you know, you see here at Bryan will drop from 86.4 to 79, and from 86.4 to 80.6. And this is the Houston district. The Houston district will drop from 78.6 to 73.1, or from 78.6 to kind of 76.3. And these curves show the cumulative distributions of the scores for the network. If you look at the ride scores really matched very well, you know, because we have a very good process in place. You know, this is for Bryan district, and this is for the Houston district. You know, for our ride scores, we have our equipments get certified every year at the certification facility at TTI. So, you know, the variability is minimum. The variability in the scores between TxDOT and the vendors was coming from variations in the distress score. So now when you look at the cumulative distribution of the distress score from vendor 1 and vendor 2 versus TxDOT, you can see that we're going to see more distresses when we move to automated or semi-automated. So this is the curve for the Bryan district, and this is the curve for the Houston district. And actually for a vendor, you know, for the Houston district, this kind of the curve to the right, you can see that kind of it's reasonably matching well. So some of the observations that that we need to know, that when we switch to automated, semi-automated, we expect our scores to go down. One reason is we're going to be able to see more cracks. You know, right now the raters sometimes they're not able to see the cracks that are not sealed. They're able to see more the cracks that are sealed. Plus, for routing measurements, we're going to move away from a 5-point acoustic sensors to a full laser transverse profile. So we're going to be able to pick more routing with the new system. One of the findings from the study that the differences between the vendors and our current process are not consistent and vary with district. Again, like I mentioned, the differences in condition scores are mainly due to the differences in the distress scores. As you saw, the ride scores matched really well. We think that the transition from manual to semi-automated measurement will give us a more efficient process. It's going to give us a safer process instead of, raters driving on the shoulder of the road. I don't know how they do it in Houston and Dallas. Fortunately, we didn't have any incidents so far. And we will be able to capture more surface distresses. And right now, when we move to automated, we're going to eliminate the subjectivity or reduce the subjectivity in the rating process. So this is kind of the proposal that it got accepted, I think, by the administration. Pavement data collection, or the automated / semi-automated data collection, will be outsourced to a vendor. TxDOT will do verifications of the data with the staff from TTI. The skid data collection will stay in-house using TxDOT equipment and TxDOT operator. And we see that moving in this direction can help with kind of allocating some of the resources to do other kind of work. And our branch and district will work on kind of coordinating the efforts for verification and skid data collection. Next, since we're making a major change and we're switching from visual rating to automated, we felt that this is the time, if we need to make any changes to PMIS, that would be the time to do it. And so there is a working group formed from 7 districts, including pavement engineers and directors of maintenance, that's looking at some of the utility factors. And the utility factors are basically the weights that affect the scores. Everyone complains about, about patching affecting their scores, so this is the first thing that we're looking at. So this is the equation for calculating the distress score, which is 100 times the U, the utility or the weight factor for the different distress: shallow rut, deep rut, patches, failure, alligator, block racking, long, and transverse. And this is for CRCP, that's the spalling, the punch out, the asphalt patches, and the concrete patches. And this is the equation for jointed concrete. These are failed joints, failures, shattered slabs, slabs with longitudinal cracks, and patching. So that's what goes into the calculations of those distress scores for the 3 different pavement types. So we're looking at, the group is looking at adjusting the factors for ACP patching, adjusting the factors for rutting, adjusting the factors for patching, for CRCP and jointed. I know jointed is not written here, but we're also looking at the effect of patching on CRCP and jointed. And we also want to look at the effect of ride, especially for concrete pavements. Sometimes we have a pavement that the distress score is 100, but the condition score is below 70 or 60. It's because ride and the metro district doesn't want to put an overlay to address the ride, and this section will continue to be a substandard section. There was a research project that was done by TTI maybe 4 years ago. Tom Freeman was involved in this research project. And this research project recommended changes to the utility factors to reduce the effect of patching on the scores. As you can see from this curve, the blue line is our existing utility factor for ACP, and the red line is the proposed utility factor from the research project. As you can see, if you have like 15% patches, it will kind of, yeah, so if you can see here, if you have 10% patches, that here will knock your score by 25%. Here we're kind of reducing it kind of by 10%. We have 2 different types of asphalt. We have types 1 through 5, and this is for type 7 to 8, which are composite pavements. The curve is almost the same. What TTI recommended, the curve is very similar to our current curve. And this is the proposed curve for CRCP. As you can see, the blue is our current utility curve for CRCP patches, and the red is the proposed. So you can see, we're trying to minimize the effect of patching. And we have 3 sets of curves for JCP based on traffic levels. This is for low traffics. As you can see, kind of this is the proposed. We're shifting the curve up to minimize the impact on scores, the impacts of patching. This is the medium and high. I'm sure everyone is interested. Okay, these are the curves. How is this going to affect my scores, or how is this going to affect me? So this first set of curves, this is for the Atlanta district. And these are not their scores. This shows like 66% of the lane miles that have patches have a score above 70. If we make these adjustments, instead of 66, now 72% of the lane miles with patching are going to have a score above 70. And you can see here for some county, this county here, 62% of the lanes with patching have a score above 70. This 62 moves up to 90. And here, 66% of the lane miles with patching have a score above 70. Now, the percent of lane miles with patching, is 91% of the lane miles with patching are going to have a score above 70. Again, this is for the Bryan district. For every county, you see for this county, 67% of the lane miles with patching have a score above 70. This 67 goes to 85. Some of the 52 goes to 75. 50 goes to 56. 29 goes to 49. I'm presenting it for every district by county. Then I'm going to present it as a district. Then I'll present the percent lane miles, good or better. So this is again for Childress. You see here this county, the percent of lane miles with patching. The percent lane miles with patching that have a score above 70 are 16%. That moves up to 76%. And you can see all, the lane miles that have patches, they're all going to move up. We're going to have more lane miles with patching that will have a score above 70. This is Childress, and this is Dallas, and this incorporates both ACP, CRCP, and JCP. We wanted to evaluate one thing at a time before we move into ride and rutting and these things. We wanted to handle patching first on its own. So you can see that, the lane miles with patching that will have a score above 70 will move up for all counties, except Tarrant stays the same. And this is Laredo. This is San Antonio. And this is now, we're going to look at it by district. So for Amarillo district as a whole right now, 38% of their lane miles that have patching have a score above 70. This goes to 66. For Atlanta, 67-82. Bryan, 54 to 71. Childress 51 to 87, 39 to 51, 49 to 66, 40 to 56, 46 to 65. So the lane miles with patching, we're going to have the lane miles with patching, the majority of them are now having a score above 70. The next is, how will this affect the percent lane miles, good or better, for the district? This is the performance measure that we report. This is how kind of the district is evaluated. So the changes are kind of, you see, some district, they will jump about 4 points or 5 points. Like here, Amarillo gets a jump of about 5 points. Atlanta gets a jump of 2 points. Bryan gets a jump of 4 points. Odessa gets, Childress gets a jump of 4 points. You know, Dallas 3 points. Laredo 3 points. You know, San Antonio 2 points. And overall, when you combine all the districts, we got an improvement of a 2%. Actually, a 2% is kind of significant. In summary, I kind of presented the trends for the pavement condition trends. We saw an improvement. I discussed the move towards automated distress data collection and the review of the utility factors. The working group is going to still meet and discuss this result. I don't know if they're going to say this is good. Maybe we need to reduce the effect more. You know, we have a meeting kind of scheduled in a week or so to go over this result and to see what's the next step. That's all what I have. I'll be ready to answer any questions. Yes, Steve?
Okay, utility factors.
Yes, sir.
Is there any thought given to, and would you consider the definition of patching versus utility factor and the definition of some cracking versus utility factor? I want to know when I've got patching out there, but I don't consider strip seals down the wheel paths patching. I mean, I know in the big picture of the way districts are rated, utility factors are pretty effective, but when you're trying to look at a road and analyze what you're trying to do, and I know I'm giving them a lot to repeat, but I'm trying to make my case that
the question,
that can be misleading.
The question from Steve, are you looking only at the utility factors or are you looking also at the definitions of the distresses? The working group is also looking at the rules that defines or constitutes what's a patch. So we're looking at the rules in the rating manuals to see if we need to make any adjustment or changes.